question show time. Your questions, my answers. As always, wherever you are across my channel, a question pops into your brain, just write it down, I'll gather them up, and I'll answer them here. Of course, there were a million questions about Venus, so let's start with that, and then we'll go into some of the other questions. Lisa Brown. Is it possible that microbes originated on Earth, hitched a ride on the Venera rovers, and made their home on Venus? That was by far the most common question comment that I got on the most recent video about Venus, or all of the videos we've done about Venus. And so a lot of people want to know, could life have hitched a ride from Earth to Venus? You know, when we think about how we want to keep our spacecraft clean so we don't infect Enceladus or Europa, whoops, we thought Venus was safe, couldn't infect Venus. Maybe there was microbes on board Venera. Probably not. For starters, just the environment on Venus is so bad, even high up in the cloud tops, even where the temperature and pressure are equivalent to Earth, the sulfuric acid is so powerful. It's more powerful than any environment than Earth life has ever been found. So no Earth life can survive in the kind of environment that we know of is in the cloud tops of Venus. So maybe life did catch a ride. Almost certainly life caught a ride on the Venera spacecraft, went through the atmosphere of Venus, and then just died a horrible death, either as they passed through the cloud tops and they got burned by sulfuric acid, or as they fell down lower into the atmosphere, landed on the surface, and then they were in this 475 Celsius temperature, 90 atmospheric pressure, crushing pressure. But let's say that there was some weird, super exotic form of Earth life that was on the spacecraft. They survived in the atmosphere, and they're replicating, have been replicating for decades. That still wouldn't explain a planet-wide signal that is accounting for 20 atoms out of every billion atoms in the atmosphere of Venus. So it's highly unlikely that Earth life could survive the trip to Venus. Nothing that we know of could survive in those kinds of environments, and yet it's impossible that life could get started and fill the entire biosphere in this short period of time. Maybe in a few 100 million years, but not in the short term. John Johansson. For many years now, I've been arguing to spray the upper atmosphere of Venus to seed it with earthly extremophiles to break down that unfriendly atmosphere as a start of terraforming. You're not the only person to suggest this. In fact, back in 1965, Carl Sagan wrote a historic paper on Venus, and he suggested that exact same thing, that we send extremophiles to Venus, they combine with the carbon dioxide, sequester it away, die and fall down to the surface, and eventually sort of lower the atmospheric density of Venus. But the problem is that you need hydrogen for organic life to be able to sequester carbon dioxide. You need to have hydrogen to go along with this process. And the problem with Venus is that it is incredibly dry. Very, very few hydrogen atoms. Any hydrogen atoms that are freed up into the atmosphere of Venus rise high up, and they are hit by the solar wind because Venus has no large magnetosphere like Earth does. And so any free hydrogen in the atmosphere of Venus is kicked out by the solar wind, and that has dried out the atmosphere. So in order to be able to terraform Venus using some kind of extremophile, you would need to deliver large amounts of hydrogen in the form of water. So you could crash many comets, asteroids into the atmosphere of Venus that would deliver a ton of hydrogen, bring in your extremophiles, and start to convert that atmosphere and lock it away into things that then you can bring down that atmospheric pressure. Evan Koch. This is not very interesting. Life is just a word. I'm interested in life I can interact with, see without a microscope. Has nobody here seen Avatar or Star Trek or Star Wars or any other science fiction story where there are alien animals and plants and beings with at least human level intelligence? Alien civilizations? That is interesting. Some microbes are not. When officially proven, it will be on the front page of the newspaper for maybe 2 days, and then it will just be yesterday's news. And nobody except for a handful of scientists will give a damn. I know I won't. Well, I want to first recommend a better use of time management. If you're going to be watching videos that you're not interested in, that is not the best use of your time. But to take it to the next level and then write a big long comment with lots of capitalization, that's even haven't you got better things to do to comment on a video that you didn't enjoy about a topic that you have no interest in? Anyway, I'm not going to argue with your time management skills, you be you. But yeah, for the rest of us on this channel, and I guarantee 99.9% of the people on this channel are super excited about the idea of finding microbial life anywhere else but Earth, because it is the first step. It would be the first instance ever seen of life anywhere else in the entire universe that isn't here on Earth. And if we can find that, then it brings up this whole other question, which is, are we related to that life? Was there some event that somehow connected our planet with Venus or with Mars or with Enceladus? Are we all related? That would prove that life is somehow making its way around the solar system. And if we're not related, then that would mean that life formed independently in other places, maybe multiple places. And if that's the case, then it means that life is almost certainly across the entire galaxy, across the universe, everywhere you look. If it forms independently multiple times in this one solar system, then it means that if you go far enough, you're going to find your aliens with ridges on their foreheads and imperial star destroyers and whatever science fiction has told you. Also, I don't recommend that you get science fiction to inform you about what is likely out in the universe. It's just a story. Geekrickson. It's probably not biology. Well, let me start by saying I agree with you. It is almost certainly not biology that is causing the phosphine atoms that are appearing in the atmosphere of Venus. That said, the researchers did a very, very careful job over 3 years of literal silence. They didn't tell anybody what they had discovered, trying to figure out anything that could explain what they were seeing. Did they make a mistake in discovering phosphine? First, they used the James Clerk Maxwell telescope. Then they used the Atacama Large Millimeter Array, which is like one of the biggest telescopes, most powerful telescopes in the world. And you got the signal of phosphine, and you got this higher resolution signal of phosphine with the bigger telescope. They are absolutely certain they are seeing phosphine in the atmosphere of Venus. So now, what produced it? And so the second half of what the researchers did very carefully was to look at every single possible non-biological source that could produce phosphine. Lightning strikes, volcanism, meteorites striking the atmosphere, factories, some way that the phosphine is produced on the surface of the planet and somehow making its way up into the high atmosphere. They looked at every single one of these, did the math, and none of them could account for this. So they took every single, what's called an abiotic process that we know of. And one of the great things is that phosphine is an atom that's been known for a long time. And so we know how phosphine is produced in our factories, by life, and other non-biological ways. And they weren't able to make any of those fit. So either it's life, which would be amazing. As I mentioned earlier, it would be one of the greatest discoveries in the history of science. Extraordinary claims require extraordinary evidence. But the other possibility is that there's a new mechanism for producing phosphine that we didn't know of. And that's also very exciting because it allows you to rule out phosphine as a biosignature in certain situations. And as we look out to other planets across the Milky Way, we're going to be seeing potentially this phosphine signal. And before this discovery on Venus, we'd look out to these other places and we'd say, oh, we've seen phosphine. That's almost certainly some kind of biology. But now we can say, okay, we went to Venus and we scanned it very carefully and we couldn't find any mechanism. And in fact, we found this weird chemical process that we didn't know before. And now we have to be a little more careful when we see phosphine in the atmosphere of an extrasolar planet. So it's a very exciting discovery, whichever way it goes. It's probably not biology because that would be incredible. But even if it's not, it's still an exciting discovery. Peter Lutz. Phosphine is also found in the atmosphere of Jupiter. Yeah, phosphine is a common molecule in the atmospheres of Jupiter and Saturn and any hydrogen-rich planet. Keep in mind, Jupiter is almost entirely hydrogen. It's hydrogen and it's helium. And same thing with Saturn. They've got this thin layer at the very top cloud deck, which is like ammonia and other kinds of chemicals, water. But then you go down about 75 kilometers on Jupiter, and it is hydrogen and helium pretty much all the way down with maybe some rocky elements in the middle. So it's not surprising that you see a molecule that is mostly hydrogen in an atmosphere of a planet that is mostly hydrogen. But hydrogen is a very reactive element. It wants to combine with oxygen. And so in a place like the Earth, which has a lot of oxygen in the atmosphere, then the hydrogen gets stripped away and oxidizes with the oxygen and turns into things like water. And you may not realize it, but there's a ton of oxygen in Venus as well. Carbon dioxide, carbon, oxygen with 2. So there's a ton of oxygen in the atmosphere. And so individual hydrogen atoms will be, the phosphine atoms will get broken up by sunlight and chemical interactions, and the hydrogen atoms will bond with other chemicals, and you will no longer see the phosphine. And so what's amazing is that there is this phosphine. There should be some process that is stripping it away out of the atmosphere of Venus, and yet we see it in large enough amounts that something has to be resupplying the phosphine. And so it could be life, and it could be some new abiotic process that we don't know of. Either way, very exciting. Connor Paller. What happens when a spaceship launching another company's payload explodes? Does the launch company pay them? Is there a spaceship insurance company? Always been curious about that. This is the first time I've had a chance to be able to talk about spaceship insurance companies. Yes! So there is, of course, an insurance industry that is built up around insuring spaceflight. And there are dozens of these companies. And on average, the companies across the world pay about $5 million for satellite insurance for their launch. And the whole industry is actually about $700 million. So it's a very big industry. And so what that will cover is if the launch vehicle explodes, if the launch vehicle fails to raise your satellite to its proper orbit, if the launch vehicle crashes your satellite into people's stuff, then it will cover all of those liabilities. So yeah, whenever a rocket fails to reach altitude and the satellite is destroyed, then the insurance company jumps in and will pay for the completion of a replacement satellite and a new launch. And so in many cases, this is absolutely required, that if you're going to launch a satellite, you pay for your launch insurance as part of your overall mission costs. And if anything goes wrong, then you get a recovery. Now, I'm sure a lot of you are wondering, what about something like James Webb? I mean, almost $10 billion, decades of development. Is there an insurance policy for that? And the answer is no. If the missions are so big, they're so critical, they are self-insured. And what that really means is not insured. And if the mission fails, then NASA will have to decide whether they're going to invest the money to build a replacement. But let's just not even think about that. More questions in a second, but first I'd like to thank Future Hog, Matt Cohen, Stephen, Rory Sweet, UC Steve, Roberto Noguera, and the rest of our 898 patrons for their generous support. Want our videos early with no ads? Join our community at patreon.com/universetoday. Trevor Henley. If Jupiter and Saturn are gas giants, what keeps them in a spherical form? Wouldn't the gas just go everywhere? Gas is just a phase, man. It's not an actual type of element. So you can take any element that you want and you can have it be in any of the phases. It can be solid, it can be liquid, it can be gas, it can be plasma. And it's just a matter of temperature and pressure. Now, when you take hydrogen, which if you took a bunch of hydrogen and released it into the atmosphere here on Earth, it would expand into a gas because the boiling temperature of hydrogen is lower than the room temperature of the air around you. Now, if you lived in a very, very cold room, then the hydrogen would turn into a liquid, and if it was even colder, then it would freeze. But pretty much anywhere on Earth, hydrogen will be a gas. And so when you're in space, actually the temperature is very, very cold. But more importantly, you've got the mutual gravity of an enormous amount of hydrogen that is pulling it together. In fact, that gravity is so strong that that it's very, very hot. I think it's 30,000 degrees centigrade at the core of Jupiter. It's not a star, but it's very hot. And when you're deep down in the core of Jupiter, hydrogen is compacted so tightly that it acts like a metal. And that's why Jupiter has a planetary magnetosphere. And as you go higher and higher up, in Jupiter, closer to the surface, then the density gets lower and lower, and eventually it's hydrogen acting like some weird ice, and then later it's hydrogen acting like some kind of weird slushy liquid, and eventually, just at the very outer levels of Jupiter, probably the top, say 75 kilometers, it has an atmosphere that is actually free floating above the rest of Jupiter. And the atmosphere is like water vapor and then surrounded by various ammonia gases and ammonia ices. But it's the gravity, it's that mutual gravity. And in fact, Jupiter is the same stuff that the sun is made out of. And the sun holds a sphere. And again, it all just comes down to that mutual gravity. It has enough gravity to pull itself in together. So that's why they're able to be spheres and not just float away. Gray. My son asked, what if the moon was in geosynchronous orbit? I walked him through it, but it seemed like a good question show question. Stay safe, stay healthy. Okay, so the moon currently orbits at a distance of about 385,000 kilometers away from the Earth. So geostationary orbit is about 36,000 kilometers away from Earth. And geostationary orbit specifically is this spot where if you're orbiting the Earth, you are able to stay, it appears from the Earth, right? You make one orbit every 24 hours. And so from the surface of the Earth, when you're looking up at the satellite, you're seeing the satellite remain motionless in the sky. Now it's still orbiting once a day, the Earth is turning once a day, and so the satellite is just there all the time. So what would be the implications? Well, the first implication is that the moon would no longer appear to orbit the Earth. The moon would always be in the exact same spot in the sky. So one part of the Earth would always see the moon, and one part of the Earth would never see the moon. If you wanted to go to see the moon, you'd have to go to that place. Maybe it's, I don't know, Europe. So only Europe gets to see the moon, and then whatever is on the other side of the world, apart from Europe, never gets to see the moon. So that would be sort of a visual thing. But the moon would be much, much closer, right? 10 times closer. And in fact, it would cause a significantly higher tidal effect on the Earth. So tides would be, I think, hundreds of meters high, not a few meters high, because it's so much closer to the Earth. But the tides wouldn't change. So you would have this permanent bulge that was being pulled up from the Earth that was being attracted by the moon's gravity. And so on the near side, if it just suddenly moved closer, then on the near side, you'd have water levels rise up and just completely cover whole chunks of the Earth. And on the other side, the water would on the sides of the Earth, the water would pull away. And then on the back of the Earth, the water would bulge up again. So that would be weird. But you still would see the moon go through its regular phases. So don't do it, I think. It would cause a catastrophe on Earth if you were to go ahead and do this. Talk your son out of this. Harlock MBB. Hi Fraser, the astronauts at the International Space Station experience a real lack of gravity, or is it more like an endless free fall? For example, if the ISS was a super tall building with the astronauts in the top floor, would they experience lack of gravity? Yeah, when you imagine the astronauts that are on the International Space Station, your mind is that it's kind of like being underwater, and that you are moving around as if you ever swim underwater and you sort of have this feeling when you're swimming around underwater, and it's, if you feel comfortable swimming, then it's not a very uncomfortable feeling. And that's because you're still experiencing gravity on all your body, your internal organs, everything. You're being held in a weightless environment, but you are still experiencing gravity. The feeling of flying in space, the weightlessness, is the same as the feeling of falling. So it is really, the feeling is like when you first press a button on an elevator and the elevator goes down. You know that feeling as your stomach goes up? Or when you're on a roller coaster and you go over the top of the roller coaster and you start to go down, and that feeling of falling. Or the best example is if you've ever jumped off of something really high into water. We do this all the time here in Canada. We have a lot of waterfalls and stuff that we jump off of. And so you can sometimes jump for 10 meters or higher. And so you really feel the falling. So imagine that feeling of course, anyone who's skydived, right? Imagine that feeling of falling, but it never ends. That is the feeling of being in space. Now, I've never done it, but I have asked this exact question to astronauts, and they have described it. And the weird part is that over time you get used to it. So in the beginning, you know, it's just this terrifying, very unsettling, very stomach churning feeling of falling and falling and falling. Your body is freaking out. Then eventually your body just sort of gets numb to it. And then this is just the new normal and you become a space person. So, but yeah, it is falling. Defa. How efficient would a rocket propulsion system have to be able to use the interplanetary interstellar medium as fuel? I imagine a device in front of a spaceship that collects the material and some sort of ion engine at the back. Great question. And not surprisingly, people have thought about this. So back actually in the 1960s, 70s, there was this idea called a Bussard ramjet. And I'm sure a bunch of people watch this like, Bussard ramjet! So what it would be is you would have a spaceship with a fusion drive inside. It would use hydrogen, it would compact hydrogen fuel down, and then it would fire it out the back. And so what the ramjet would do is it would have this scoop in front of it called a ram scoop. And it would use a big, gigantic magnetic net that it would redirect particles from space as the spacecraft is moving through space, as it's moving through the interstellar medium, and it would be redirecting them down this funnel, and it would be compacting it tighter and tighter and tighter until eventually it could get it tight enough to ignite fusion on it, and then it would fire it out the back of the rocket, and that would cause it to accelerate and accelerate and accelerate. And the faster you got, the more fuel you could suck in, and the faster you could go. The problem with this idea is, one, how do you generate a magnetic field that could be thousands of kilometers across? That's one problem. Nobody knows the answer to that. But the other problem is that it now looks like the density of the material in the interstellar medium isn't enough to supply a Bussard ramjet with enough fuel. Like, we now know that there's about 10 atoms of hydrogen in every cubic meter of space. And that's just not enough. But people have thought about ideas of doing that here in the solar system, where you could maybe feed off the solar wind. In fact, Robert Zubrin and collaborators have got this idea where you take a spacecraft and you point it into the solar wind, and then you just absorb particles coming off the solar wind. And as long as you're close enough to the sun, you can use that as a way to accelerate your spacecraft. The other idea is that you could artificially lay a trail of fuel in front of your ramjet. So you could, for example, fire out some kind of trail of hydrogen fuel or pellets or something like that in front of the spaceship. And so as it's accelerating, it's passing along this trail and it is gathering more and more material as it goes. So, you know, obviously, these are all just incredibly crazy science fiction ideas, but there's some ideas that I really like here in the solar system, like the idea of an air-breathing ion engine. So you have a spacecraft that is orbiting the planet close enough that it's actually able to bring in particles from the atmosphere of the Earth and then use electricity to then fire those particles back out of the ship as a thruster. And so you have no propellant that you have to carry on board, and you get all of your electricity from the sun. And so the thing can fly forever, as long as where you want to fly is really close to the Earth, almost within the Earth's atmosphere. But over time, maybe we'll think of other ideas. It's a great concept. I mean, if you can live off the land in interstellar space, that would be ideal. Gennaro Canero. Hi Fraser, talking about black holes and primordial black holes, is there a theory model to explain the supermassive black hole? Are they thought to be primordial black holes, or models support a black hole merge approach? So you're asking one of the unsolved mysteries of the universe right now, one of the big challenges in astronomy. So I'm not going to be able to answer the question, because if I did, then I get a Nobel Prize. And I'm just a journalist. But I can help you sort of understand where we are in the problem right now. We now know that there are these supermassive black holes that seem to be at the heart of every single galaxy out there. And it seems to be that the size, the mass of the supermassive black hole grows in tandem with the size of the galaxy itself. As the galaxies get bigger, the black holes get bigger. And the farther and farther that astronomers are looking, the earlier in time that astronomers are looking, they're seeing galaxies which are too evolved. They're more evolved than they should be. They have black holes, supermassive black holes at the heart of them that are more massive than you would think there would be. And if you run the calculations, right, there is a limit to how much a black hole can eat. If a black hole is just nonstop at the buffet, just feasting as much as it can. There's still a limit to how big a black hole can get because the material just chokes up, has to wait its turn to die. But black holes can collide with each other. And that's one way that you can get black holes to suddenly double their mass, triple their mass, right? But the other idea is this idea of a direct collapse black hole. So you have some gigantic cloud of gas and dust, of like primordial hydrogen left over from the Big Bang. And one set of theories says, well, maybe you could just have this big cloud of material and it just swirls around and collapses down. And instead of turning into a star that then throws out stellar winds that blows away all of the material from trying to add to the size of the star, the whole thing just collapses directly into a black hole. No intermediate step. And maybe you could have these be significantly bigger than the size of the black holes that are possible today. You know, back in the early universe, had this pure primordial hydrogen fuel that was more efficient than the fuel that they have today. It's all, you know, well, it's got all this grit from stars, star formation. So that's sort of like one idea for how you could have black holes grow very big to get to this supermassive black hole size. Now, you talked about this idea of primordial black holes. We've talked about this a couple of times in previous episodes. This idea that there were ripples in space-time over densities at the earliest moments of the universe where they kicked out tiny black holes. But the reality is there's no limit to the size of these black holes. They could be as big as the observer, they can have as much mass theoretically as the observable universe. Now, we don't see that. We see a universe and not just one big black hole. Therefore, that didn't form, but there could definitely have been far more massive black holes formed in the over and under densities in the original universe, which then went on to accrete more mass or merge together to build up. Somehow we got where we are today with supermassive black holes. There had to be some chain of events, and it could have been primordial black holes as the first nuggets that then merged together, or direct collapse, or just some other sequence of black holes forming, merging together, giving us the black holes that we see today. I think we'll have an answer to this in the next couple of decades, probably sooner. And so this is one of these things to keep an eye on as the science continues to evolve. Harry Ayers. Can we observe rogue intergalactic stars? When we look out in the Milky Way, we see a vast collection, 100 to 400 billion stars all collected together into this one gigantic island of stars. Then we look away, we see Andromeda, we see even more stars over there, but are there stars in between? And the answer is yes. In fact, the Hubble Space Telescope has directly observed collections, individual stars that are in the space in between our galaxies. They are millions of light years away from Earth, and they're not connected to any one of these galaxies. And so it's thought that these things have got to be everywhere. In fact, it's thought that maybe they account for anywhere between, say, 10% of the mass of stars are just not in galaxies at all, to much more, maybe even approaching the mass of galaxies that are out there. And for the longest time, this was thought that maybe this is an answer for dark matter, that, yeah, when you've got all these stars collected together into one location, then it's very bright and we can see it. But when you've got this diffuse stars that aren't connected together, then they're not giving off enough light that it could explain it. But they would give off a signal in the intergalactic medium, a way that heated up, that should be obvious, and astronomers have looked for this. But now astronomers have actually seen these individual stars. I think back in 1997, Hubble Space Telescope was able to detect some of these stars in the intergalactic space. So yeah, absolutely, there are rogue stars, and there are probably tiny collections, tiny star clusters, tiny amounts of stars out there, just in these vast gulfs in between galaxies. So imagine like growing up on a world and not being able to see the Milky Way above you, but seeing other stars around you, and that's almost certain to be out there. All right. Here ends the question show. Thank you, everybody, for asking all your questions. I think this is a lot of fun. As always, wherever you are, across my channel, if a question pops in your brain, just write it down. I'll gather them up, and I will answer them here, and I'll see you next week. If you want a single, comprehensive resource for space news, you'll want to subscribe to my weekly email newsletter. Every Friday, I send out a magazine of space news with dozens of stories, pictures, brief highlights about the story, and links so you can find out more. Go to universetoday.com/newsletter to sign up. It's totally free. Did you know that all of my videos are also available in a handy audio podcast format so that you can have the latest episodes as well as special bonus material like interviews with me show up on your audio device? Go to universetoday.com/audio or search for Universe Today on iTunes, Spotify, or wherever you get your podcasts. And I'll put a link in the show notes.